Systems of equations with different units of measurement. Descriptive models with different units. We have learned to write and solve a system of equations with the same units when modeling a word problem. But how would you go about doing this if the units of measurements were not the same? What we need to do is determine the appropriate quantities with proper levels of accuracy to model the problem for different units of measurement. Our practice with converting units will be very useful for this process. Example number 1, low-flow toilets. A public water conservation program offers low-flow toilets that cost $123.50. These toilets only use 1.6 gallons of water per flush. A family has a traditional full flush toilet that uses 3.5 gallons of water per flush and is considering replacing it with a low flush toilet. On average, the family flushes the toilet 20 times per day and pays $0.005 per gallon of water. There's 3 parts to this problem we're going to consider. Part A, we want to create a model to determine the cost savings for a family to purchase and use a low-flow toilet in terms of the number of days. B, we want to determine the number of days before the family will start saving money. Part C, this is an extension. 1 year after the low-flow toilet is purchased, the cost of water increases by 4%. Create a new model to determine the cost savings with the increase in the cost of water. Use your model to determine the number of days before the family will start saving money. This is what we're given so far. So out of this problem, out of this situation, we learned that there's a low-flow toilet that costs $123.50. The water usage for the low-flow toilet is 1.6 gallons per flush. The full-flow toilet water usage is 3.5 gallons per flush. Water costs $0.005 per gallon of water, and the family averages 20 flushes per day. So let's create a model to determine the cost savings for the family to purchase and use a low-flow toilet in terms of the number of days. So we're going to calculate the water cost per day of the 2 toilets using unit conversions. So down here, I have the full flush toilet, and we're using the information we know about the full flush toilet, that it's 3.5 gallons of water per 1 flush. The family averages 20 flushes for a day, and the cost is $0.005 per gallon. So I cancel out my units. You'll see with the blue line, we canceled out the unit of flushes. With the reddish line, we canceled out the unit of gallons. We're left with the units of dollar per day, which is what we want. And performing our arithmetic, we find out that the full flush toilet cost 35 cents a day to flush. Now let's consider the low flow toilet. The low flow toilet uses 1.6 gallons per flush. The rest of the information is the same, 20 flushes per day, and the cost per gallon is the same. So once again, I cancel out the units of flushes. I cancel out my gallon units, perform the arithmetic, and we see that the low flow toilet will cost 16 cents per day. Starting down here, there is a one-time only cost for the purchase of the low flow toilet known as the fixed cost. That is up here, $123.50. The original purchase of a full flow toilet was in the past and is now known as a sunk cost. The sunk cost does not affect future cost, so it is not used in the model. So remember, we are creating a model to determine the cost savings for a family to purchase and use a low flow toilet in terms of the number of days. We've determined that the fixed cost for the low flow toilet is $123.50. The total cost of operating the low flow toilet, which we'll designate with the variable y and the subscript low flow, is the fixed cost plus the number of days in use, we'll designate with the letter x or the variable x, times the daily cost. This is the mathematical expression that we create. Y, with the subscript low flow, is equal to 123.50 plus the 0.16x, which is the cost per daily use. We're going to do the same thing for the full flush toilet. So there is no fixed cost for the full flow toilet. It's already in the present. The total cost of operating the full flow toilet, which we'll designate with the variable y and the subscript full flow, is the number of days of use, and the days we'll designate with the variable x, times the daily cost. So y, with the subscript full flow, is equal to 0.35x. Remember that our goal is to create a model to determine the cost savings for the family. So the cost saving models per day, which we'll designate with the variable c, is going to be the difference between the cost of the two toilets. So the low flow cost $123.50 per day, plus the 16 cents per day usage. And then the full flow toilet, we're going to subtract from that cost. It's going to be 35 cents per day. Combining our like terms is going to give us a simplified expression. The cost savings model is C is going to be 123.50 minus 19 cents per day. Let's continue on with example number 1 by looking at part B. So in part B, we are to determine the number of days before the family will start saving money. Now there's 3 observations we're going to make about this cost saving model that we just developed. The first observation is that when C is greater than 0, the family has spent more money than they would have spent if they just kept the full flow toilets. The second observation is that if the model is 0, this is what we call the break-even point. The same money would have been spent whether or not the full flow toilet was replaced with the low flow toilet. And the third observation is that if the cost-saving model is less than 0, the homeowner will continue to save money by replacing the full flow toilet. The more days that the low flow toilet is present, the more money is saved. So in math world, when you're talking about spending money, spending money with a negative number is equivalent to savings. So keep that in mind. If you're talking about spending money and you get a negative number, that would be the same thing as saving money. Let's continue. So our strategy is this. We're going to set C equal to 0 to find the number of days that elapsed after the full flow toilet is replaced for the family to start saving money. Here's the work that we see. So we start with our cost saving model. I set C equal to 0. And by replacing C equal to 0 and solving for x, we find out that the break-even point is 650 days. So at 650 days, that's the break-even point. Let's see what happens before 650 days and after 650 days. So I'm going to pick any number before 650 days. I'm going to pick x is equal to 600. So at 600 days, how much do they spend? Well, let's say when x is equal to 600, I replace x with 600. So I take $123.50 minus 19 cents per day, 19 cents times 600, and that is equal to $9.50. So they would have spent $9.50. Now let's pick a number bigger than x, or bigger than 650. Let's try 700. So when x is equal to 700, I take my cost-saving model, C is equal to $123.50 minus 19 cents per day for 700 days. That comes out to be negative $9.50. So that negative spending is another way to say savings. On day 700, they saved $9.50. So our conclusion here is that after 650 days, the family will save more money after every day that the low flow toilet is installed. Now let us consider part C of example number 1. Recall that part C reads as follows. 1 year after the low-flow toilet is purchased, the cost of water increases by 4%. Create a new model to determine the cost savings in dollars with the increase in the cost of water. Use your model to determine the number of days before the family will start saving money in this scenario. So first of all, we want to determine if the family still owes any money on the low-flow toilet after 1 year. So what you'll see I'm doing is I'm going to take my cost model and I'm going to replace X with 365. Okay, so 19 cents times 365 is $69.35. Subtract that from the cost of the toilet, and we see that after 1 year, the family spent $54.15. So here's the analysis. The family would have spent $54.15 more than if they had just kept the full flow toilet. This is the new fixed price for the analysis, as it already took into account the price of the low flow toilet. So starting right here, since the price of the water has increased, with the 4% price increase, we're going to multiply the previous water cost by 1.04. And that gives us a new water cost as follows. The full flush toilet, which was 16 cents per day, multiplying that by 1.04 gives us a new cost of $0.166 per day. Now for the low flow toilet, that was 35 cents a day. Multiplying that by 1.04 to calculate the 4% price increase gives us a new price of $0.364 per day. So the cost model needs to be modified. The new fixed cost for the low flow toilet is $54.15, expressed right here. So the Y with the subscript low flow is the new model is going to be $54.15 minus the 0.166 for each day times X. And for the full flush toilet, that new model is going to get replaced with 0.364 times X. Now remember, the cost model is going to be C is equal to Y with the subscript low flow minus the cost of the full flow. So that's going to give us our cost savings. So I subtract the two equations and simplify expressions, and we end up with $54.15 minus 0.198 times X. So now I take this and I set C equal to 0 to find the number of days before the family starts saving money after the water price was increased. So you'll see here I take C is equal to 54.15 minus 0.198x. I set C equal to 0 and solve for x, and I find out that x is equal to 273 days. So the total number of days that it would take the family to start saving money is 365 days before the price increase, plus another 273 days after the price increase, which is equal to a total of 638 days. So with the price increase, it took 638 days for them to save money. Not a big difference, but they will continue to save money after this period. Let us consider this first practice scenario concerning light bulbs. Electricity companies are encouraging the use of LEDs, which means light emitting diodes, which use 25 watts of energy each. The LEDs are sold in packs of 6 at a cost of $20. A family uses 36 100-watt incandescent light bulbs. Their plan is to replace all of their current bulbs with LED lights. The bulbs are turned on an average of 10 hours per day at a cost of $0.015 per kilowatt hour. There's 3 parts to this practice scenario. Part A, calculate the cost in dollars per day to operate each type of light. Part B, how much per day per light will the homeowner save by replacing a bulb with an LED? Part C, create and solve a model to determine the cost savings in dollars for the family to purchase, replace, and use 36 LEDs in terms of the number of days. This is the information we're giving so far. So let's summarize this. So from that scenario, we learned that LED power is 25 watts per LED. The LED cost is $20 for 6 LEDs. The incandescent light bulb power is 100 watts per bulb. The incandescent light bulb cost is $0.015 per kilowatt hour. And the number of bulbs/LEDs required is 36. Now we're going to turn our attention to calculating the cost of 25-watt LEDs. So calculating the cost of 25-watt LEDs, we're going to have the following scenario. We start with our 36 light bulbs, and then we multiply by this ratio right here, which is 1, because 25 watts per bulb, that is a ratio of 1. 1 kilowatt hour is the same thing as 1,000 watts, so this ratio here is also equal to 1. From above, we see that it's $0.15 per kilowatt hour, and then the family averages 10 hours per day. Crossing out our units, bulbs with bulbs, watts with watts, kilowatt with kilowatt, hour with hours, we're left with 2 units, 0.015 over 1 day, that's dollars and days. Doing the arithmetic by multiplying across the top and dividing by 1,000, we get our cost is $0.135 per day. Now let's turn our attention to the 100-watt bulbs. So pretty much everything is the same except for this fraction right here. It's 100 watts per bulb. Everything else is the same all the way across. So when we perform the arithmetic, we find out that the cost per bulb with an incandescent bulb is 54 cents per day, $0.54 per day. And now we're going to move on to Part B. And Part B reads, how much per day per light will the homeowner save by replacing a bulb with an LED? So right up in here, we have all of our previous information, which we've carried over. Let's just review some of the new stuff. So here we have the LED cost is $0.135, and the daily cost for a bulb is $0.54 or 54 cents. Now here we have that the savings per light per day per light will be the bulb cost minus the LED cost. So the bulb cost is 54 cents right here. So that's the bulb cost. The LED cost is 0.135. We subtract that off, and our final answer is the savings per day is going to be 45 cents per day or $0.45. And now we're going to move on to Part C. Part C reads, create and solve a model to determine the cost savings in dollars for the family to purchase, replace, and use 36 LEDs in terms of the number of days. So here again, we have the information we've calculated, the cost of LED bulbs, the LED daily cost, the bulb daily cost, and we just calculated the savings per day per light. Now let's keep something in mind here. There is a one-time only cost for the purchase of LEDs. That's known as the fixed cost. The fixed cost the fixed cost to replace all 36 bulbs with LEDs is going to be as follows. We take the 36 LED lights and we're going to multiply that by $20 for 6 LED lights, and the answer is going to be $120. Now just keep in mind, I'm going to show this part here. We are going to cross out our units, so LEDs with LEDs, multiply 36 times 20, and divide it by the 6. And that's how we get our $120. So continuing on, we have just calculated that the fixed cost to replace all 36 bulb LEDs is $120. the total cost of operating the LEDs, we're going to abbreviate with this right here, Y with a subscript of LEDs. That is the fixed cost. So the fixed cost right here is $120 plus, there's my plus sign, the number of days X times the daily cost. Okay, and the daily cost for LEDs is up here, 0.135. So our final equation is going to be Y with a subscript of LEDs is equal to $120 plus 0.135x. And now we're going to calculate the cost for the bulbs. Well, let's keep in mind there is no fixed cost for the bulbs. Okay, no fixed cost. But the total cost of operating the bulbs is, we're going to designate with Y with a subscript of bulbs. It's going to be the number of days, which is going to be X, times the daily cost. Now the daily cost for operating light bulbs is up here. That's 54 cents. So our equation is going to be Y with a subscript of bulbs is equal to 0.54 times X. Now we're going to move on to where we're going to calculate the cost savings model, which we're going to call C, and that is going to be the difference between the total cost of the bulbs and the LEDs. So this is going to be important. Let me get my highlighter out here. It's going to be C is equal to Y with a subscript to LEDs minus Y with a subscript to bulbs. Now, Y with the LEDs, that is going to be 120 minus 0.13x. And the bulbs is going to be 0.54x. So we're going to subtract those two. And when we combine our like terms, okay, here's my like terms. I'm going to take 0.135x minus 0.145. And we get a new equation, which I highlighted in yellow. C is equal to 120 minus 0.405x. This brings us to Part D. Part D, use the model to determine the number of days before the family starts to save money. Now, there's three scenarios we need to consider. So when the cost savings model C is, let's consider the first scenario, greater than 0, a positive number, the family has spent more money that they would have spent if they had just kept the bulbs. Okay, so if the cross 0 is positive, they spent more money doing this replacement. They would have been better off just keeping the bulbs. If the answer is going to be 0, so the cost saving model is equal to 0, that is the break-even point. The same money would have been spent whether or not the bulbs were replaced with LEDs. In the third scenario, we're talking about when the cost saving model C is less than 0. When that's less than 0 or a negative number, the homeowner will continue to save money by replacing the bulbs. The more days that the LEDs work, and that's measured in years, the more money is saved. So if you think of it this way, the cost savings model is how much money they're spending. Okay, they're spending money to run these LED bulbs. And you're comparing the cost savings per bulbs versus LEDs. So if you're spending money, once you get to negative, you're doing the opposite of spending. What's the opposite of spending? Saving. Now we're going to move on to Part D. And Part D is asking us to use the model to determine the number of days before the family starts to save money. So here's our strategy. We're going to set C equal to 0, find the number of days that elapsed after the light replacements for the family to start saving money. So I take my equation, here's my model here, and we have C is equal to 120 minus 0.405x. I set this equal to 0 and solve for x, and we find out that at 296 days, the cost is going to be 0. That's the break-even point. So I'm going to analyze this a little further before I read the next sentence. What happens if x is less than 296? So let's say C is equal to 100. Okay, C is equal to 100. And 100 is certainly less than 296. So I take my equation and I replace x with 100. So it's 120 minus 0.405 times 100. So C is equal to $79.50. What that means is on day 100, they spent $79.50 replacing the light bulbs with LEDs. Okay, so they didn't start saving money yet. But what happens after 296 days? Let's pick on any number of days after 296. I'm going to pick arbitrary number. I'll pick 400. 400 days, that is certainly greater than 296 days. And by the way, you can pick any number you want. I'm just picking random numbers. So C is equal to 120 minus 0.405 times 400. When I do the arithmetic, that's going to be equal to a negative $42. So what does that negative mean? That means they didn't spend $42. What's the opposite of not spending $42? Saving $42. So they saved $42 on the 400th day of having these LED lights. They saved $42. So in my final analysis right here, what we're going to say is that after 296 days, the family will save more money after every day that the LED lights were or LEDs were in service. Here's our second practice scenario. This one deals with shower heads. A water conservation program offers low flow shower heads that use 2 gallons of water per minute, priced at $54. A family is considering replacing their current shower head, which uses 5 gallons per minute, showers for 20 minutes daily, and pays $0.002 per gallon for water. Here's the three scenarios we're going to consider. So, A, we're going to create and solve a model to determine the cost savings in dollars per day for the family to purchase, replace, and use the low flow shower head. Part B, how many days before the family starts saving money? Part C, 1 year after the low flow shower head is purchased, the cost of water increases by 5%. Create a new model to determine the cost savings with the increase. Use the model to determine the number of days before the family will start saving money. This is the information we are given so far. Low flow shower head cost $54. The water usage for the low flow shower head is 2 gallons per minute. The water usage for the current shower head is 5 gallons per minute. Their current cost is $0.002 per gallon, and their daily shower usage for the whole family is 20 minutes per day. For scenario A, we want to create and solve a model to determine the cost savings in dollars per day for the family to purchase, replace, and use the low flow shower head. So we're going to calculate the cost per day of the 2 shower heads using the unit conversions. So we'll start with the current shower head, which uses 5 gallons per minute. The family showers for 20 minutes per day, and the cost is $0.002 per gallon. We cancel out our units, gallons with gallons, minutes with minutes, and we are left with dollars per day, performing the arithmetic by multiplying across the top and multiplying along the bottom. Dividing, we end up knowing that the cost for the current shower head is 20 cents per day or $0.20 per day. Now let's look at the low flow shower head. Most of the information is the same except for the very first fraction. We're replacing 5 gallons per minute with the flow rate for the low flow shower head, which is 2 gallons per minute. We still cross out our gallons. We still cancel out our minutes. Performing the arithmetic, we see that the low flow shower head cost 8 cents per day. So now that we're going to begin creating our model. So the cost for the low flow shower head is $54. The cost for operating the low flow shower head is the fixed cost plus the number of days in use, which we're using the variable X, times the daily cost. So here's our abbreviation, Y with a subscript of low flow. There's our fixed cost, and there's our daily cost. So this is the expression Y sub low flow is equal to 54 plus 0.08x. And now we're going to find the cost for the current shower head. Now right now there's no fixed cost. Okay, so there's nothing to add. But we do know that the total daily cost is 20 cents. So we're going to use Y with the subscript to current is equal to 0.20x, 20 cents per day. We're still using this information up here, and we're still trying to create and solve a model to determine the cost savings for dollars per day to each family. So here's how we're going to develop the model. So we're going to use the letter C to represent the cost savings per day model, and that's going to be the difference between the two shower heads. So it's going to be the low flow shower head minus the cost of the current shower head, which is going to be the low flow is 54 plus 0.08x minus 0.20x, and the simplified result is going to be C is equal to 54.08 minus 0.12x. So now we're going to set C equal to 0 to find the number of days that elapsed after the current shower head is replaced for the family to start saving money. So using our model, C is equal to 54.08 minus 0.12x, I'm going to set this equal to 0. And the reason why I'm setting this equal to 0, this is the break-even point. This is when the cost for the two shower heads are exactly the same. And that occurs at 451 days. So after 451 days, the cost for the two shower heads are the same. Now, what happens before 451 days and what happens after 451 days? Well, let's consider, pick an arbitrary day before 450 days. So let's say x is equal to 400. It's supposed to be an x. So what I do is I replace x with 400. So C is going to be equal to 54.08 minus 0.12 times 400. And that is going to be $6.08 per day. I'm sorry, $6.08 at day 400. So after 400 days, they have spent a total of $6.08 using their regular shower head. Now let's pick an amount of days, arbitrary days after 451 days. So let's just say x is equal to 500. So sometimes after 451 days. So this time I replace x with 500. I have 54.08 minus 0.12 times 500. And that gives me a value of C is equal to negative $5.92. So this negative right here, let's talk about that. What does that negative value mean? We're talking about how much the family spent, okay, after replacing the shower heads. So after 450 days, that's when the cost is the same. The cost is 0. After that, if they're spending a negative amount of money, that means that they're actually saving. Okay, so negative spending is the same thing as saving. So they're actually saving money after 451 days. For example, on day 500, they saved $5.92. So our end result in our analysis down here is that after 451 days, the family will save more money after every day that the low flow shower head was installed. Now let's move on to part C, and this is the scenario for part C. 1 year after the low flow shower head is purchased, the cost of water increases by 5%. Create a new model to determine the cost savings with the increase. Use the model to determine the number of days before the family will start saving money. So here's our plan of attack. First, we're going to determine if the family still owes any money on the low flow shower head after 1 year. So we take our cost model And we come here and we see that our cost model is C is equal to 54.08 minus 0.12x. I replace x with 365 because there's 365 days in a year, and x represents the number of days. And performing the arithmetic, we find out that after 365 days, the cost is $10.08. So here's our final analysis. The family would have spent $10.28 more than if they had just kept the full flow shower head. This is the new fixed cost for the analysis as it already took into account the price of the low flow shower head. Now remember that the price of the water has increased. With the 5% increase, we're going to multiply the previous water cost by 1.05. Okay, why are we multiplying this by 1.05? Well, remember that 100% is the total cost of the original or total original cost, but there's a 5% increase. So 100% is equal to 1, and 5% is equal to 0.05, and that's how we get our 1.05. Okay, it's a 5% increase is counting in the original amount. So I take my current shower head, which costs 20 cents per day, and multiply that by 1.05, and we have 21 cents per day. For the low flow shower head, that was 8 cents per day, but with the 5% increase, that comes out to be $0.084 per day. So modifying our new cost model, the new fixed cost for the low flow shower head is $10.28. I'll highlight that so we can see it. So the model for the low flow shower head is Y with the subscript low flow. There's the cost, the fixed cost, plus the daily cost, 0.084 times X. Now the current shower head, there is no fixed cost up front. We're just going to take into account the daily cost, which is 21 cents per day or 0.21 times X. Now, for the current model, okay, we're going to take the cost of the low flow shower head minus the cost of the current shower head, and we're going to subtract the two. So we take 10.28 plus 0.084x minus 0.21x, and our new model is right here. C is equal to 10.28 minus 0.126x. So now we're going to use the model to determine the number of days before the family will start saving any money. So right here, starting, we're going to set C equal to 0. And the purpose of that is to find the number of days before the family starts saving money after the water price was increased. So I take my new model, set that equal to 0, and solving for x, we're going to see that x is equal to 81.6 days. So the total number of days that would take the family to start saving money is 365 days before the price increase, plus the 81.6 days after the price increase. Adding those two together, we find out that's equal to 446.6 days. With the price increase, it took 446.6 days for them to save money. Not that big of a difference compared to our previous model.